Hello, and welcome to another Lunch and Learn from Roofers Coffee Shop. My name is Heidi Ellsworth, and we are bringing this to you in the roofing companies to really be able to learn about what's happening out there. And sometimes it's the best beginner's information. So as you watch this Lunch and Learn, think about inviting your whole team in from within the office so that you can really find out really great stuff. Today, we're going to be talking about insulation and coverboard. Very excited about this. It's a 101 that's really going to help us understand from the very beginnings. As a reminder, a few housekeeping notes that we do have a discussion sheet. So be sure to download that discussion sheet before you watch this with your team and make notes for a couple reasons. One, so you can discuss all this great information amongst yourselves, but also Roofers Coffee Shop has launched a quiz for every Lunch and Learn. So you can get a certificate of watching this and also maybe win a box of love from Roofers Coffee Shop. So be sure to get that discussion sheet. After you watch this, go to the quiz online and take it. It'll be great. So let's get started. I am very excited to welcome our guest who can really help with this Lunch and Learn, tell us what's going on, Jeff Job with John's Manville. So Jeff, welcome to the show.
Thanks, Heidi. Happy to be here.
I'm really happy to have you. This is important. It's hard to understand all these different components, all the different systems out there in commercial roofing, but to really be able to help your business grow, whether it's in sales or the front desk, you need to have this information. So today, with your help, we're going to discuss 3 learning objectives. Learning objective number 1, insulation 101. What is it? Learning objective number 2, coverboards 101. What are they? The third learning objective is the overall application and benefits of ISO coverboards. So, Jeff, let's get started.
Sounds good.
Okay, so learning objective number 1, insulation 101. What are the types of insulation that are out there, Jeff, and what should people be aware of?
So, Heidi, there's really 3 main kind of product, I guess, call it categories, if you will, as far as rigid foam boards in the roofing world. There are a couple other materials out there, rock wool, as well as some vacuum pack materials that have a very small portion of the market. But for the mass majority, the rigid foam boards are going to drive, 90+% of the market for the most part. So kind of 3 component or 3 groups out there, if you will. There's your styrene products, both expanded and extruded. And then there's polyisocyanate as well.
Exactly. Can you tell us a little bit about each of those insulation types? What are some of their features and some of their limitations?
Sure. We'll go ahead and start off with polystyrene. We'll talk about extruded. Extruded polystyrene, a couple benefits being high compressive strength. All these products are going to be, fairly lightweight and rigid. So from a kind of a compressive standpoint, they're all going to hold up pretty well. You can get some higher compressives with your XPS boards, extruded oftentimes referred to as XPS. Kind of a moderate R value, I would say. So of course, in the insulation world, we're shooting typically for the highest R value per inch to kind of maximize the efficiency of that system. So XPS kind of coming in about the middle there compared to some of the other products. Another benefit of XPS is going to be its moisture resistance. So it does do well with moisture. It's not really going to be impacted by it that much. It's really not going to absorb it that much. Oftentimes that's why you'll see it used below grade, foundations, retaining walls, things like that. Very popular product for below grade as well due to its moisture properties. I would say on the limitation side of things, fire performance typically being kind of paramount with any of your styrene. So whether it be extruded or expanded, fire performance tends to be somewhat of the Achilles heel of those products. Okay. Oftentimes, that might drive a decision one way or another regarding what the requirements are of the system and the performance of the material. Can they meet said requirements? So that would be kind of one drawback on the XPS side is generally poor fire performance compared to some of your thermoset materials.
And what about polyiso?
Polyiso is going to be typically probably the best really option out there from a call it ROI standpoint, at least, the bang for your buck, if you will, the amount of thermal resistance you're going to get with that product. compared to the styrene products. So better thermal performance, typically, on average of, 5 to 6 per inch, kind of depending on how you're using it. We could go into, a lot of different wall applications where 6R per inch tends to kind of be the standard. In the roofing world, we're kind of under different requirements. We are held to the LTTR standard, which I will save for another day. That's a bit of a, kind of a rabbit hole, but nonetheless, LTTR wise, we're looking at typically around 5.7 in the industry per inch is kind of the standard there. Couple other benefits of polyiso versus polystyrene. What I mentioned it already, polyiso is a thermoset material versus polystyrene being a thermoplastic. So when we get into kind of fire performance, that does have a significant difference. The polyiso will char versus kind of melting away like a polystyrene. So from that perspective, thinking of, again, approvals, fire performance overall, polyiso does seem to shine above the styrene products from that perspective as well. So again, just kind of some of the additional benefits there on the ISO side of the styrene products.
That helps a lot because you need to know exactly kind of what are the limitations, what are the benefits of each of those. But there's also some things I just want to talk about, some other parts of the insulation. And all insulation, I'm thinking most insulation has some sort of facer. Can you, first of all, tell all of our listeners what is a facer? And then what are the different types and kind of what should they be looking for?
So all insulation does not have facers.
Okay.
All a polyiso does. Those are typically always made with a facer on both sides. Your styrene products, as we were talking about previously, generally they're going to be extruded or expanded in that manufacturing process, which does not require a facer. So some drawbacks and benefits there as well on whether or not you have a facer. I'll start with maybe some of the drawbacks of a facer, and then we can touch on some of the benefits. So I would say the most standard product out there from a polyiso standpoint in the industry is going to be your paper-faced standard reinforced paper facer, oftentimes referred to as GRF or glass reinforced. So that's a standard facer out there, widely used amongst the industry. The key component kind of being in that conversation being paper, right? So there is paper, there is cellulose in that facer. That cellulose can absorb water. It can potentially lead to mold, bacteria growth, things like that if the water stays in there for a period of time and is unable to get out. So that is kind of one typical drawback from your standard paper facer out there. I would mention too on the moisture absorption standpoint too. We talked about that on the XPS side. From an ISO standpoint, the foam core itself really will not absorb any moisture. Generally, all that moisture absorption is occurring in that facer component. So if we change out that facer to something else that's maybe more water resistant, able to essentially get wet and not be impacted by that, for example, a coated glass facer, then you've kind of eliminated the drawbacks related to that paper facer. So if we use a coated glass facer, again, coated glass, a glass mat typically coated in a kind of a mineral substance, inorganic, so no cellulose, no paper, not going to absorb any water, will not be a source for mold growth, things like that. So that tends to be the higher quality facer being used in the roofing industry. A lot of other benefits related to that CGF facer being its ability to work with adhesives really well. So if you're doing an adhere job, that tends to be the facer of choice. One, because it won't absorb as much of that facer, right? We just talked about it's going to resist water absorption. So for example, again, on a paper facer side of things, if you're using adhesive, that paper facer can kind of soak up some of that adhesive, and you will typically not get as good of coverage rates as the literature on that particular adhesive might say. So on a lot of adhesive, it's going to typically have a range of coverage based on how tight the pattern you're putting down, how much you need to put down based on typically the uplift requirements of the system. If you're using a paper facer, you're going to be on the lower end of whatever that range is, just due to the fact that it's going to absorb more of that adhesive.
Right.
CGF, on the other hand, coated glass, you're going to get higher coverage rates. So if you're doing a large adhere job, going with a CGF facer is going to extend the coverage rate of that adhesive, typically to the higher end, thus allowing you to kind of maximize the benefit of that adhesive. Anybody in the roofing industry understands when we're talking about securement methods, adhesives typically quite a bit more expensive than your traditional fasteners. So if we're spending extra money and going with an adhered system, switching to a CGF facer can help extend the your coverage rate and really maximize the use of that adhesive. Another benefit being fire performance. So we'll kind of get into that a little bit more, I think, here when we talk about some of the cover boards and things. But you can get a significantly better fire performance with a coated glass facer over again a paper facer, right? So if you need certain approvals, you're putting ISO or some other material, a cover board over a combustible deck. Do you need a Class A fire rating? In a lot of cases, you can achieve a Class A fire rating directly over a combustible wood deck, going with a coated glass type face product. So that's kind of another benefit there, allowing you to again achieve better fire performance just by switching out the facer.
That is see, I think those are the kind of things that a lot of times people aren't aware of, that, you have these options and you have these different ways to really get where you need to be. I would love to kind of take what you just said and then push that over into the insulation attachment methods, maybe talk a little bit about tapered, but also just overall, what are some of the best practices when you're talking about insulation?
Sure. So a couple, we'll start with, I'll touch on tapered briefly, and then we can kind of go more into the attachment side of things. Obviously, in roof, whole point of a roof is to essentially, keep water out, for lack of a better term, right? That's a key component of the performance properties of a roof deck. One way we typically do that is sloping the roof deck. Code's going to require typically a minimum of a 1/4 inch slope. Some municipalities greater. So that said, we have to have some type of slope to the roof to allow water to drain off that system. Can be done a number of different ways. You can physically slope the structure. You can add tapered insulation, another key option there. The beauty of tapered really being it kind of adapt to any system, right? So, for example, if it's certainly a large roof, maybe you have skylights, lots of penetrations for whatever reason, mechanical systems, etc. The tapered system can be laid out really based on any call it geometry of the roof, what the shape of the roof is, penetrations, etc., where your drains are, scuppers. So you can take that information, submit it to a manufacturer, and anyone who manufacturer who's typically has the capability to provide tapered material will do design in-house for that. So they'll take that, they'll lay out where all the sloped panels need to be based on your drains, etc. So a lot of different kind of tapered options out there, depending on, of course, the slope requirements, secondary drainage requirements, things like that, can really kind of be, even from like a retrofit standpoint as well. Maybe you don't have enough slope, or there's ponding for whatever reason. Coming back and kind of retrofitting a system with tapered when you're maybe doing a tear off and a re-roof, adding some slope to that system, supplemental slope, things like that will all be ways to again achieve the required slope requirements for that project, and can be done in a lot of different fashions. It's really pretty flexible. So that from a tapered perspective, again, we could kind of go down a rabbit hole on a lot of different things specific to that, but nonetheless, just kind of some of the high level benefits of tapered on a roof deck. So securement methods, really typically, I would say with ISO specifically, very compatible, right? So kind of across the board, whether it be, adhesives, mechanically fastened, hot mop, asphalts, things like that. Really, those products are going to be able to function compatibility wise across all the standard securement methods. So it shouldn't really, that shouldn't be kind of a really driving a decision of what type of securement method you're going to use. Really, it's more of the membrane, uplift requirements, location. Are we doing ballasted? Are there other, solar array, things like that going on that might steer you one way or another from a securement method standpoint? So really, the ISO can kind of function in all those systems. So whether it be, mechanically fastened, induction weld, adhered in a lot of different ways, it can really achieve all of those. And I would say too, kind of from a best practices standpoint, you might have heard the term fasten one, adhere one, or variations thereof, where typically in a lot of cases, say there's multiple layers to a roof insulation package, which is again not uncommon. Typically, kind of best practice again would be, say, code requirement, the energy code says you need 4 inches of insulation to meet whatever the R value requirements are for the location of your project. Instead of kind of doing one 4-inch layer, typically we're going to do two 2-inch layers, and you're going to offset the joints of those boards to help you kind of maximize the thermal performance of that system. So, for example, if we're going to attach our first layer, we're going to mechanically fasten it typically. Again, mechanically fastens tends to be the least costly option. So mechanically fasten that first layer, and then oftentimes we can come back and adhere the second layer. Is what that does is it helps break the thermal conduction of that fastener through the roof system. It's going to help offset your joints. So if there's any air movement through that roof system at the joints of the boards, those two components can have an impact on the thermal performance of that roof system, right? So for example, if we had a fully mechanically fastened system, say our R value, our insulation package is an R value of 30, which is a pretty common number nationwide. That fastened system, those mechanical fasteners are acting as conduction points through that wall system or that roof system. So they're essentially kind of having an opposite effect of what the insulation is doing. They're conducting heat while the insulation is trying to resist heat. So with that said, a fastened system's your on paper performance is not going to be as good as what's actually happening on the job site due to those physical connections. So you do lose some actual R value in a fully mechanically fastened system over a fully adhered system, or even what we might refer to as a hybrid, or again, a fasten one, adhere one, where we're going to fasten that first layer, then adhere that second layer to again create that thermal break in the system, and then we're not spending the extra money to adhere the bottom layer as well. So you kind of get a good middle ground, I would say, in high performance, in that we're not spending all that money on additional adhesive where we don't really need it, but we are including it where we do to help break those thermal. So that's kind of a nice combination.
Yeah.
Again, you can really do fully fastened all the way through the membrane, laps, etc., or do fully adhered all the way through as well. Fully adhered systems tend to be a little more costly and tend to be also higher performance too. So again, a lot of it's just trade-offs of what the objectives of the project are, the owner, et cetera, those kind of things.
And what they're looking for. That makes total sense. And the thing I'm hearing is lots of options, which is really good because you can fit it towards the project as you want. So, okay, great. Let's go to our second learning objective, and that is Coverboards 101. So let's start with a very simple question, Jeff. What are coverboards?
They're essentially just a key thing with a coverboard is really just call it a resilient layer to add to your system to help protect the two main cost buckets of your roof system. That might be kind of a weird way to put it, but really it's a protective layer that's protecting your insulation below, and it's protecting your membrane above. So any roofer is going to be pretty aware of that. From a low slope standpoint, the two biggest cost components of a roof system are going to be the insulation and the membrane. So the addition of a coverboard can go a long way in helping protect both of those, kind of high cost components of a system. So that's kind of the beauty of the coverboard. Lots of different coverboard options out there. Just kind of some of the key highlights, right, are going to be, of course, impact resistance, whether it be people walking on the roof, whether it be hail impact, service maintenance, again, maybe, solar array type applications, how that's going to support or protect that insulation package below. Because of course, if we start compressing that insulation, puncturing that insulation, damaging it, then now we've lost the thermal performance of what we paid for. So kind of, again, call it an insurance component package to add to that system, right?
Right. And there's a lot of reasons that you need it. I mean, there's when you're looking at this, and I'm probably jumping a little ahead, but I think this is important, is impact resistance, water, all of those things are really helping to protect those two, the insulation and then the membrane.
100%. So it's, again, I would say kind of just to add to that too, right? I mean, I think fire resistance is another one that we didn't really speak to specific to coverboards. So again, gyp coverboards, coated glass face coverboards do have, kind of better fire performance than some of the other ones. It could also be, depending on the type of membrane you're putting down, and the insulation you have below. In some cases, you might need, what was often maybe referred to as a barrier or some type of, material in there to separate the insulation from that membrane, because there can be a potential for reactivity, or certain membranes don't necessarily function well with some of your styrene products. Typically, EPS can be somewhat of an issue. So again, adding that barrier board in there, or that cover board in there, is going to, again, allow you a nice, flat, rigid surface to then adhere your membrane to, or attach your membrane to. So that's another added benefit as well. Overburden protection, for example, if, again, ballasted systems, things like that, you're certainly going to want additional kind of compressive protection in there to help, again, support that, the insulation below, as well as, you think of a membrane, right? If you got a hail ball impacting it, if it doesn't have anything below it to kind of support it, then there's going to be potentially more damage on that membrane, versus if it's got a nice, hard, robust surface to kind of resist that impact. That's great from the membrane perspective.
Then you get a bounce.
Hopefully.
Hopefully. Well, when you're talking about common coverboard materials, basically coverboard can be used. I mean, we'll talk a little bit about that, all the different systems and what is usually recommended.
Sure. Yeah. So we kind of maybe did jump ahead a little bit on performance versus kind of what's available to the industry. Really, I would say kind of three groups out there, kind of similar to the insulation, right? We have our high density high density polyiso insulation cover boards, gypsum cover boards, and then what I'd consider kind of wood fiber is the other category, but that can be a lot of different things. It could be, asphaltic boards, perlite, things like that kind of fall into that high temp bituminous application for the most part. So hot mop, for heat welding, things like that, generally you're going to want to use an asphaltic board or perlite that are going to be very high heat resistance. Most commonly out there are going to be your HD ISO cover boards, again, your high density polyiso, and your gypsum. Widely compatible across all different types of membranes for the most part. Couple benefits to really the HD ISO over maybe some of the gypsum boards. One being lightweight, right? I think we could obviously understand foam is a lot lighter than gypsum. Oh, excuse me. So lightweight's a nice benefit there, as well as also the kind of the ability from a logistics standpoint of how much material you can ship or load a roof with, right? So we've seen applications. We've had a number of them this year where they couldn't point load the roof at a certain weight. So they had to either reduce the pallet size of a gypsum board, or they had to spread that out, or we had to do something where we couldn't just simply load the roof deck with traditional pallets out there. Generally with polyiso, that's not an issue. It is significantly lighter than a gypsum product cover board, on average, probably 4 to 5 times lighter than your kind of traditional gypsum board. So that's kind of a nice benefit there over the gypboard products. Again, really from a compatibility standpoint, though, I would say a lot of it's just going to be driven on, what makes sense for that project. If it's a super high compressive situation, or there's a really high fire rating, things like that, that might drive you to gypsum. For the most part, the vast majority of system requirements out there, you can get away easily with an HD ISO cover board from a performance standpoint, as well as save yourself some of the labor savings. So again, being able to ship more material to a job site as well. So you can put more material on a truck, just like loading a roof deck. You're loading a truck with something that's significantly lighter. You can put a lot more material on that truck and ship a lot more squares to a job site versus you can with a gypsum product that tends to be heavier. So kind of another benefit that's maybe not thought of or considered oftentimes with your HD ISO cover board over a gypsum product.
Excellent. Okay, I think this leads us perfectly into our third learning objective, which is ISO cover board design considerations and benefits. So we kind of started on that. I know we got a little excited there, but let's, one of the things I kind of wanted to talk about up front is, as we're talking about design considerations, how much insulation is necessary on roofs?
Sure. Really, it's driven by energy code. So, and that's typically a lot of that's based on ASHRAE 90.1 is kind of tends to be the model standard that a lot of municipalities are going to use as a reference, or the actual, I codes, IECC, for example, generally adopts or references a lot of the standards that are coming out of ASHRAE. Nonetheless, what energy code or what requirements are for your job site is going to be driven typically by obviously what energy code, what version of that's been adopted in your market or in that area that the project is, and that's really driven by the climate. So colder climates tend to have higher insulation requirements versus warmer
Yeah.
ones, and that's all based on what they call degree heating days, which is an ASHRAE term that essentially says or is alluding to the number of days that you're heating that structure throughout the year. So of course, colder climates are typically you're going to heat the building more often. Thus, the prescriptive requirements state that you need more insulation in that thermal envelope to really help resist the need for energy consumption. So that's kind of the high level concept or idea of what's happening with energy code and how we get to where we get. But really, it's just driven off a location and what that municipality has adopted for the energy code in said specific location. So it varies pretty widely. I threw out that R30 number. That's pretty, I would say about half the country kind of falls under the R30 requirement.
Okay.
And then again, of course, as you get warmer into the southern climates, less so, if any, insulation is actually might be required in that particular area. So it
Right.
does vary widely. And then of course you have, California's got its kind of own unique statewide code. So
Always.
kind of a lot of variation there again, but for the most part, the energy code is really just going to drive a lot of that. And then there's significant trade-offs based on building type, other performance requirements that are being put into the building. So again, certainly, fairly easy to track down that information, but not as kind of black and white of, hey, I'm in climate zone 5. I know it's automatically this.
Right. Right. And the nice thing is, and I know we're going to talk about this at the end, but Johns Manville has all those kind of resources too to help people kind of figure that out. So we'll get back to that also. Okay, let's talk about on the ISO coverboard design, the benefits of that ISO. Can you kind of, I know we talked a little bit about before, but walk through us, what are the benefits of using that?
Yep. So I would say at least, in pretty much most of the ISO coverboards out there are going to be pretty similar. It's high density polyiso, a coated glass face coverboard, and that can drive a lot of different things. Of course, we've mentioned the fire performance. So again, you can get Class A fire ratings with this coverboard directly over a combustible wood deck. So you can put that down, put a membrane over the top of it, and that's going to meet the Class A requirements per UL in a lot of cases. So that could be done there. Another kind of benefit is going to be your fastening patterns. So a more rigid board than your typical insulation, right? Going to have more wind uplift resistance. So with that said, you can oftentimes get away with fewer fasteners in an adhered system. So if you're having preliminary securement of that coverboard through that insulation package before you adhere your membrane, oftentimes you can use less fasteners than you typically would need to if you're just going direct to the insulation below. So that's kind of some of the trade-offs there, right? Again, too, as far as going with the additional cost of a coverboard can be offset by cost savings in some of the other components, potentially less adhesive. If it's a CGF board, less fasteners in a lot of cases. A lot of manufacturers have kind of a varying I'd say capabilities around how many fasteners they allow per some of the uplift requirements. So at least with JM, right, we can get an FM 190 with 8 fasteners per board with our standard HD ISO coverboard. Some of the other manufacturers have similar, some have higher. So it kind of just depends on what testing they've gone through. So that's another huge one there. We spoke to kind of the lightweight nature of it as well.
Right.
Great for adhered systems. So those tend to be kind of the main standouts, I would say. And then again, a lot of it's just going to be based on, kind of logistics too of what's going on that job site, what makes sense for the owner and the contractor.
Yeah. And the thing that we've already talked about is it does so well with fire, wind uplift, hail impact, all of those different things, foot traffic. I think those are all important too. We kind of talked about those earlier, but those are strong benefits. So I think one of the last things I would love for you just to talk about is the big performance benefits with relatively low initial cost. That is a big push, especially for the Johns Manville systems. Kind of talk a little bit and bring us home on that.
Yeah, I mean, I think I would say, essentially, I kind of like to go back to the call it the return on investment, right? That, using a coverboard is going to give you significant protection of your insulation package, very good, robust kind of substrate to adhere your membrane to. And it's generally, in the grand scheme of things, it's probably a 10% cost component when you factor in labor and everything else. Whereas those other two components are, 40, 50%. So, I mean, those are huge cost drivers, right? So mixing in a coverboard is really going to allow you to protect those major components. It's going to help, especially with your guarantees too, right? So JM, we're big in the guarantee world, what we're going to allow, 20, 30 year guarantees, right? Generally, almost all those are going to require a coverboard because it's going to really add to the longevity of that system. You can, recover applications as well. So you could have it, if you're just doing a recover, throw down a coverboard, go right over the top of it with another layer of, another membrane, right? HDISO also has a residual R value. So we kind of forgot to mention this earlier on when I was talking about HDISO in relation to gypsum. There is some residual R value there too, right? So you can get additional R value in that system, depending on the thickness of the board, of course. You can get, more or less R value. Put that down. Again, I'm going to drive a lot of conversations around hail impact. Another one too. I don't want to go down the whole very severe hail conversation, but again, FM has different requirements out there based on locations of the country. That if it's an FM job, right, they want you to have specific requirements around, what the impact resistance of those systems. So coverboards are critical to meet any kind of VSH, very severe hail impact rating out there. Definitely any system out there is going to require a coverboard at this stage. So very kind of, I don't want to say critical, but what we consider best practice would be using a coverboard. Again, and the gypsum ones tend to be very high performance, very competitively priced. And again, you can get some of the other trade-off benefits of, less components, fasteners, securement based on the type of facer you're using there. So offset some of the cost of that coverboard as well.
Okay. Jeff, wow, that's a lot. Thank you so much. It's so good. Please share with us just a little bit about the Johns Manville systems and how you're using it and how people can get in touch with you or actually with Johns Manville to kind of start looking at including these systems if they're not already.
Sure. So JM's flagship coverboard is called Protector HD. So that's, again, standard high density polyiso coverboard with coated glass facers. All kind of some of the benefits we alluded to already, right? Very high uplift performance, FM 190 approvals with eight fasteners per board. So that's something we certainly like to point out. 670 squares of material on one single truck to a job site. So that's over 3 times the amount of material you could get with a gypsum product. So again, thinking of, logistics at the job site, labor, right? Labor savings is a huge one, how we can minimize that, getting more material there. Again, loading the roof deck. You can put significantly more of this material on that roof deck and stage it, have it ready to go than you could with the gypsum board product. So some of the other benefits there, that's kind of huge. Another one we like to point out with JM too is that this coverboard can be installed with hot asphalt. So kind of a unique one in this case that generally, hot asphalt and polyiso CGF boards oftentimes are not typically allowed or preferred with a lot of manufacturers. In this case, you can adhere that coverboard down in hot asphalt and then come back and put whatever standard kind of preferred membrane or bonding adhesive you want over the top of that. So that is one feature we think is somewhat unique to JM. I'd also say too, again, kind of back to the Class A thing, right? So whether it be, a coated glass coverboard or whether it be some of the other coated glass products. So we do also have a separator CGF, which is a coated glass coverboard, 25 PSI, so more of a lower PSI kind of recover type product, as well as some, any type of coated glass face, the Energy 3 ISO product as well, can all achieve a Class A over a wood deck. So especially on the West Coast, that's very popular. You do see it a lot kind of in the South as well. Some of those wood decks, you could throw any one of these products that has a coated glass facer over it and achieve a Class A. So Protector HD and Separator CGF tend to be are the two main cover boards that JM is offering right now.
That's excellent. Thank you so much. What great information. For everyone out there, of course, you can find all this information on the directory on Roofers Coffee Shop, John's Manville directory, plus by going to John's Manville, which is very easy to jm.com, and finding all this information. So Jeff, once again, thank you so much.
Thank you, Heidi. Appreciate it.
Thank you. That was great. And I just want to remind everybody to be sure to download your discussion sheet. Talk about this. Talk amongst yourself. It's always fun over lunch to have a great conversation about insulation and cover boards. We also have the quiz, so please be sure to take that. You'll get a certificate of completion, and you'll get entered in to win a box of love. And you'll get entered in to win a box of love from Roofers Coffee Shop. Thank you so much for attending this Lunch and Learn, and we will look forward to seeing you on the next one.